Every morning, millions of people look into the bathroom mirror and perform a routine ritual of hygiene, completely unaware that they are placing a substance of absolute cosmic terror directly onto their bodies. You squeeze a clean, refreshing paste onto a brush, trusting it to protect your smile from decay. It smells of fresh mint, looks perfectly harmless, and promises safety. Yet, hidden inside that mundane tube is a domesticated monster, a chemical psychopath that has terrorized the scientific community for centuries. This everyday protector is built from an element so violently aggressive that it does not merely react with other matter, it actively seeks to dominate and dismantle it in its free, untamed state. This substance refuses to tolerate the very existence of a neighbor. It is a ghost in the natural world, an entity that cannot be found pure anywhere on the surface of our planet because it instantly tears apart whatever it touches to force a union. If you were to release a cloud of this pale yellowish gas into a room, the world as you know it would simply cease to exist. Water, the universal agent used by humanity to extinguish fire, does not put out this element. Instead, water itself catches fire in its presence, burning with a fierce, unnatural flame and releasing trapped oxygen while transforming into an acid that eats through flesh and bone for generations. The bravest minds in Europe found themselves locked in a desperate, silent war against this invisible phantom. They did not seek to discover gold or unlock the secrets of alchemy, yet they paid for their curiosity with their physical integrity and their lives. 19th century chemists spoke in whispers of a dark, unwritten record, a ledger of martyrs who dared to try and isolate this single untamable element. To study it was to invite a slow, agonizing process of biological dismantling. One legendary investigator, celebrated for unlocking the secrets of highly reactive metals, met his match when he breathed in a microscopic dose of this elemental vapor. The gas did not just burn his throat, it initiated a deep, structural assault on his respiratory system, turning the remainder of his brilliant life into a breathless, suffocating struggle for survival. Two brothers from Ireland attempting to outsmart the phantom by engineering specialized containment vessels made of solid stone found that the monster always finds a way out. One brother was left paralyzed in his bed for 3 long years, his nervous system shattered by the fumes, while the other remained a permanent invalid, a living testament to the element's ruthlessness. Other young researchers, full of ambition and working at the absolute peak of their intellectual powers, were cut down in their early 30s. They died from total pulmonary destruction, their lungs literally turning to liquid because they dared to look too closely into the crucible. The element demands total submission, and for nearly 100 years it took everything its captors threw at it and turned it into ash, ruin, broken bodies. The secret to this unmatched lethality is woven directly into the fundamental architecture of its atom. It sits at the very top of its column on the periodic table, engineered by the laws of physics to be the ultimate predator of the subatomic world. Its outer electron shell is missing just a single solitary electron to achieve a state of perfect, unassailable stability. But while other elements gently share or exchange their particles, this one possesses a ravenous, localized hunger that distorts the rules of chemical behavior. It holds the absolute maximum score on the universal scale of atomic greed. This atomic desperation creates a reality where standard definitions of stability completely dissolve. Quartz glass, the global benchmark of chemical inertness used by scientists to contain the most vicious acids known to man, vanishes upon contact with this gas, melting away into a volatile vapor. The element completely ignores the boundaries that restrain the rest of the material universe. It forces ancient immovable substances like basalt rock, industrial concrete, and heavy brick masonry to spontaneously burst into cold, bright flames, oxidizing the silicon and aluminum within the stone until a solid wall turns into nothing but drifting, toxic smoke. Even the noble metals, substances like gold and platinum that can sit at the bottom of the ocean or withstand centuries of weathering without a single speck of rust, eventually surrender when heated in the presence of this predator. For the first half of the 20th century, science believed that the noble gases, the aloof aristocrats of the chemical world like xenon, were physically incapable of forming bonds with any other matter. They were thought to be completely untouchable. Yet, this singular element shattered that law, violently cracking open their perfect electronic armor and forcing them into chemical bondage. This unrelenting hostility means that every single atom of this substance on Earth is trapped in a permanent, suffocating chokehold with its immediate neighbor. It forms bonds that are so incredibly strong that breaking them loose requires an astronomical injection of raw energy. To see it pure, humanity had to learn how to replicate the absolute extremes of cosmic forces inside a fragile laboratory room. And yet, the terrestrial violence of this element is merely a reflection of the cosmic nightmare that birthed it. When astrophysicists look out into the deep void of space, they notice a strange, glaring anomaly in the composition of the universe. The elements that sit directly adjacent to our predator on the cosmic table, ruler elements like oxygen, nitrogen, and neon, are manufactured in staggering, abundant quantities by the standard nuclear furnaces of ordinary stars. They are the common currency of the cosmos, but our element is an extreme, glaring rarity, a profound bottleneck in the path of stellar creation. It cannot survive the normal life cycle of a star. Instead, it is born only within the dying, swollen bellies of giant aging stars, deep within layers where temperatures scream past hundreds of millions of degrees. In these terrifying depths, neon nuclei are forced to capture stray protons, briefly fluctuating into the form of our ninth element. But the moment it is born, it finds itself in immediate mortal danger. The same extreme conditions that create it are perfectly tuned to destroy it. It greedily swallows alpha particles and instantly mutates back into neon, for this cosmic psychopath to survive and escape into the interstellar medium. The parent star must undergo a violent, catastrophic spasm, throwing off its outer layers in a desperate mass loss before the internal nuclear reactions can consume the freshly baked element. It is a substance born on the absolute brink of total annihilation, but there is an even more violent cradle for this element, a process driven by the most elusive ghosts in physics. During the final, dying moments of a massive Type II supernova, as a giant star collapses in on itself to form a black hole or a neutron star, it releases a blinding, unfathomable flood of neutrinos. These ghostly particles normally pass through entire planets as if they were empty air, interacting with nothing. But inside the crushing, impossible density of a dying stellar core, the sheer volume of the neutrino stream becomes a physical battering ram. This ghostly torrent smashes directly into the surrounding neon atoms, violently knocking loose a single proton or neutron from their cores. This act of raw subatomic vandalism transforms the neon into the only stable form of our ninth element in the universe. Every single milligram of this substance drifting through space, trapped inside a crystal on Earth, or sitting on the bristles of your toothbrush, is the direct monument to a dying star's final, explosive scream. It is a chemical relic of cosmic murder, forged in conditions where the density of matter and the flow of energy exceed the boundaries of human comprehension. After being cast out into the freezing void of interstellar space, this cosmic ash cooled, drifting through dark molecular clouds for eons before gravity pulled it down to become embedded in the crust of a young, cooling Earth. Here, it was locked away inside deep geological vaults, bound tightly to calcium to form beautiful, glassy fluorite crystals. Early miners in the mountains of Saxony noticed that certain dark, almost black varieties of these stones emitted a sharp, suffocating stench when struck with a hammer. They called it the stinking spar, unaware that radioactive impurities within the rock had been performing microscopic acts of automated radiolysis for millions of years, slowly breaking the chemical chains and releasing tiny, trapped pockets of pure, free gas inside the crystal lattice. Human beings were accidentally inhaling the pure, untamed fury of this element 3 centuries before science even recorded its existence. In its free state, the physical properties of this substance emphasize just how deeply alien it is to any biological environment. It is a suffocating gas with a heavy, biting odor that can be detected by the human nose in concentrations of less than 1 part per million. If you cool it down to extreme temperatures, it condenses into a bright canary yellow liquid, and if you push it further toward absolute zero, it freezes into pale, brittle crystals. Because its atomic radius is the smallest among its peers, it possesses a terrifyingly dense concentration of negative electrical charge on its surface, making it the most efficient. Unrelenting electron thief in the known universe, there is no physical barrier it will not attempt to breach. The energy holding a molecule of this gas together is abnormally low, meaning the twin atoms are incredibly unstable, constantly desperate to split apart into individual, free-roaming predators ready for an immediate assault. Yet paradoxically, once this element successfully latches onto another substance like carbon or hydrogen, The resulting bond becomes one of the strongest, most unbreakable links in all of chemistry. This creates a profound, disturbing duality that defines the entire history of human civilization's relationship with the ninth element. In its free form, it is pure, unadulterated chaos and kinetic destruction, but once it satisfies its hunger, it shifts instantly into absolute, eternal stasis, a molecular graveyard where nothing can change, move, or decay. For nearly a century, humanity remained completely locked out of this kingdom, unable to find a way to break the stone locks without triggering a lethal explosion. Every attempt to isolate it resulted in the immediate destruction of the apparatus, the seals, the electrodes, and the lungs of the researcher. To catch the ultimate predator, science did not just need better tools. It required a complete sacrifice. By the late 19th century, the hunt for the ninth element had moved past the realm of academic curiosity and entered the territory of a siege. Chemistry laboratories across Europe had effectively become specialized containment zones, where researchers worked under the constant shadow of systemic biological sabotage. Glass, which had served for hundreds of years as the ultimate pristine barrier for containing aggressive matter, completely lost its integrity. Upon making contact with the phantom fumes of the element, the solid, transparent walls of flasks and test tubes would visibly soften, weeping into a thick, sticky liquid before dissolving into thin air. The race to conquer this substance had evolved into a direct, brutal conflict between the fragile machinery of human flesh and a gas that fundamentally rejects the concept of isolation. Into this arena stepped a researcher who understood that to defeat a chemical psychopath, one must abandon standard laboratory philosophy. Working within the prestigious pharmaceutical institutions of Paris, this investigator began his campaign with a series of devastating, near-fatal reminders of his opponent's power. 4 separate times, the invisible breath of the monster forced him to abruptly abandon his benches, spending months in isolation just to allow his blistered lungs and corroded airways to scar over and heal. He realized that fighting the element at room temperature was a fool's errand. Its kinetic rage was simply too fast for human reflexes. To catch the tiger, he had to systematically rob it of its thermal energy, forcing the reaction into a state of profound, artificial winter where the laws of thermodynamics would slow the monster down. The apparatus designed for this confrontation was a marvel of unprecedented expense and raw materials science, representing a financial investment that could have funded an entire university department for years. It was a single, elegant U-shaped tube forged entirely from an exotic alloy of platinum and iridium. Platinum was one of the few materials in existence capable of surviving a direct, unmitigated encounter with the gas, but it did so through a process of immediate, sacrificial protection. The moment the element touched the metal, it would instantly devour the outermost layer of atoms, creating a microscopic, impenetrable shield of platinum fluoride that effectively blunted the monster's appetite for further destruction. Every ordinary component of a standard laboratory setup had to be systematically purged, because cork, rubber, or wooden stoppers would instantly burst into blinding, white-hot flames upon the slightest contact with the vapor. The researcher engineered custom plugs carved out of pure, transparent fluorite crystal, the element's own geological prison. The reactive medium inside the tube was a specialized lethal cocktail of anhydrous liquid hydrogen fluoride, combined with a dissolved potassium salt to allow an electrical current to flow through the freezing fluid. The entire metal assembly was then submerged into a boiling bath of methyl chloride, dropping the temperature down to a staggering 50 degrees below zero. On a quiet summer morning in June, the electrical circuit was finally closed. As the current tore through the sub-zero liquid, tiny, sluggish bubbles of a pale yellowish gas began to coalesce on the platinum anode, rising slowly to the surface like a waking demon. To prove to the waiting world that he had successfully isolated the ultimate predator, the researcher took a small tube filled with crystalline silicon and held it directly against the exhaust valve. The reaction was instantaneous and terrifying. The solid silicon did not catch fire in the traditional sense. It spontaneously erupted into a cold, brilliant flame, instantly vaporizing into an invisible gas. For the first time in human history, the tiger had been successfully separated from its environment. Held captive inside a precious metal cage, the achievement earned the investigator the ultimate accolade of global science, the Nobel Prize, but the ledger of the ninth element always demands a final balance. When he stood before the committee to accept his medal, He looked like a ghost of his former self, his body structurally ruined by years of breathing invisible acidic traces. His right eye was severely clouded from an old chemical burn, his lungs were stiffening with chronic fibrous tissue, and his joints were thick and deformed from a condition where the element systematically replaces the minerals in the skeleton. He survived just 2 months after returning from the ceremony, his exhausted body collapsing under the weight of a sudden infection. He was perhaps the most illustrious and final name to be written into the original century-old list of victims. But the isolation of this cosmic predator did not lead to a peaceful era of understanding. Instead, the blueprints of the French laboratory were buried deep within the ultra-secret military programs of the mid-20th century. During the height of the Second Global Conflict, a massive wartime project realized that to unlock the ultimate energy of the atom, they first had to rely on the terrifying chemistry of the ninth element. To build the first atomic weapon, scientists needed a way to separate two nearly identical forms of uranium. The only way to achieve this was to turn a heavy, dense metal into a volatile gas that could be filtered through miles of specialized membranes. The resulting substance was a nightmare born of a nightmare: uranium hexafluoride. It manifested as white, dense crystals that, when gently warmed, bypassed the liquid phase entirely and turned into a colorless, hypercorrosive gas. The choice of the ninth element for this process was a matter of pure mathematical necessity. It possesses only one stable form in nature, meaning every single variation in the weight of the gas molecules was driven entirely by the uranium itself. But this elegant physical solution triggered an industrial catastrophe of materials engineering. The uranium gas proved to be the most aggressively destructive compound ever manufactured on a massive scale. The weapon managers were forced to construct a processing facility of impossible proportions, a giant U-shaped complex stretching for over half a mile under a single continuous roof, filled with thousands of miles of interconnected pipes and massive pumping stations. The problem was that the gas would instantly react with any ambient moisture in the air, transforming back into a vicious acid that systematically ate through standard steel conduits, dissolved copper valves, and turned standard industrial lubricants into charred, solid blockages. The entire multi-billion-dollar complex was in imminent danger of literally liquefying from the inside out before producing a single ounce of weapons-grade material. Human ingenuity was pushed to its absolute limit to find a substance that could survive inside this industrial furnace. The salvation of the project came from a completely accidental discovery made years prior, when a chemist noticed that a tank of experimental gas had spontaneously polymerized into a strange, white, incredibly slick powder. This synthetic material possessed a molecular structure, where a dense backbone of carbon atoms was entirely surrounded by a thick, protective armor of our ninth element. Because the element's greed is so total, once it forms this specific link, it refuses to let go, creating an electronic barrier that no other acid, solvent, or gas in the universe can penetrate. This revolutionary polymer, which would later find its way into the kitchens of the world as a common household coating, became the thin, critical shield that prevented the wartime facility from destroying itself. Every valve, every gasket, and every seal inside the vast uranium cascade had to be lined with this indestructible plastic. Without this specialized chemical barrier, engineered to withstand the violent appetites of the ninth element, the dawn of the nuclear age would have been physically impossible to achieve. But the real horror of this triumph was that humanity had successfully traded the tragic accidents of isolated laboratory martyrs for a system of industrial permanence that would soon spread across the entire face of the biosphere. Today, the legacy of that frantic wartime material science sits quietly in almost every household on the planet, disguised as a common kitchen convenience. When you tilt a pan to let an egg slide effortlessly onto a plate, you are witnessing the absolute, locked-in satisfaction of the most aggressive element in existence. The very same molecular shield that once corralled hypercorrosive uranium gas now ensures that your breakfast does not stick to metal. It was one of the most successful, cynical conversions of military technology in human history, transforming an element born of stellar cataclysm and weaponized for the apocalypse into a multi-billion-dollar symbol of modern domestic comfort. But this element is not a creature that can ever be truly domesticated. It merely bides its time. As the decades rolled on, the incredible, unyielding stability of the carbon-fluorine bond, the very trait that made it an engineering miracle, evolved into a profound ecological crisis. The industry required specialized processing aids to manufacture these slick, invulnerable plastics, creating a family of synthetic substances known to modern science as forever chemicals. Because the ninth element guards its carbon partners with a dense negative electronic shield, the natural world has no answer for it. There is no bacterium on Earth that has evolved an enzyme capable of breaking that artificial lock. There is no amount of sunlight, rain, or soil acidity that can dissolve its grip. For over half a century, the industrial centers of the world quietly discharged the chemical byproducts of this fluorine economy into the environment, operating under the assumption that if a substance is inert, it must be harmless. It was a catastrophic miscalculation. These molecules leaked into the global water table, drifted on ocean currents, and climbed the biological ladder. Today, medical mapping reveals that traces of these synthetic fluorine compounds can be found circulating in the blood of nearly 99% of the human population. The chemical shield we engineered to protect our machines and our cookware has effectively become a permanent, indestructible part of our own internal biology. The planet simply does not know how to clean what the ninth element has decided to protect. Away from the kitchen, the modern high-tech landscape remains entirely dependent on the controlled fury of this atomic predator. The smartphone in your pocket, the server farms powering the global internet, and the advanced artificial intelligence networks shaping the future would not exist without it. To manufacture a modern microchip, engineers must etch microscopic pathways onto silicon wafers with an accuracy measured at the atomic scale. To do this, the microelectronics industry relies on ultra-pure hydrofluoric acid, the very same substance that eroded the lungs of the 19th century martyrs. We use the elemental hunter to meticulously eat away the stone, carving the digital brains of our civilization with a scalpel made of pure chemical violence. Even the global energy infrastructure depends on this delicate dance with the monster. The vast cascades of spinning centrifuges that enrich fuel for nuclear power plants still utilize the exact same uranium hexafluoride gas developed during the race for the bomb. Every day, millions of tons of this hyper-corrosive fluid pass through industrial conduits, held at bay only by thin microscopic films of passive corrosion. We operate our modern world by keeping a tiger inside an age of its own making, fully aware that a single structural failure, a single breach of the passivating layer, would turn an advanced industrial center into a smoking, melted wasteland in a matter of seconds. This reveals the profound philosophical paradox of our relationship with the material universe. When we seek to fortify our frailties, we do not turn to gentle cooperative elements. We deliberately seek out the most terrifying, uncompromising forces in nature and attempt to weave them into the fabric of our lives. We take an element born in the catastrophic neutrino crossfire of a dying supernova, a substance that burns water and liquefies stone, and we use it to protect the enamel on our teeth, to cool the food in our refrigerators, and to build the microchips that store our collective human knowledge. We have built a civilization of unparalleled comfort, but its hidden foundations are bolted directly to a cosmic psychopath. There is a deep, dark irony in what happens when this element is allowed to saturate a biological system completely. In regions of the Earth where natural volcanic activity has caused the groundwater to overflow with dissolved fluorides, the element carries out its ultimate, terrifying programming. It enters the bodies of the local inhabitants and begins an automated thermodynamic restructuring of their anatomy. It does not ask permission. It bypasses the soft, organic logic of cell biology and replaces it with the cold, unyielding laws of geology. It stimulates the bones to grow uncontrollably, turning flexible joints into solid stone and transforming the human spine into a rigid, fused pillar of rock. It builds a flawless, indestructible skeletal fortress, but it locks the living human being inside it, transforming moving flesh into a stationary geological artifact before life has even departed. This is the ultimate warning against human hubris. The ninth element reminds us that the stability of our world is an incredibly fragile illusion, maintained only by the temporary absence of specific reactants. If the protective seals on our industrial infrastructure were to fail simultaneously, or if the atmospheric balance of our planet were slightly altered, the very ground beneath our feet would recognize its old master. The concrete of our cities, the glass of our skyscrapers, and the bones in our bodies would spontaneously ignite, returning to the ancient, stable state of inert mineral ash that the element prefers eons from now. Long after the cities of humanity have fallen into ruin and our cultural achievements have been forgotten by time, our true geological legacy will be written by the ninth element. Our fossilized remains, deeply saturated with hyperstable fluorapatite, will endure in the sedimentary strata far longer than the bones of any creature that came before us. The fragments of our nonstick pans and our microchip components will sit embedded in the rock layers as indestructible technofossils, completely immune to the decay of deep time. The ultimate predator of the periodic table, which we fought so desperately to isolate in our small, fragile laboratories, will become the final permanent archivist of our existence. It will hold our shape in the stone forever, a silent, unyielding monument to a species that dared to steal the fire of a dying giant, only to find themselves permanently captured by its embrace.